you would have studied in your C languages. In those you would have come across a keyword called volatile. Volatile means a variable whose value keeps changing. Here also in embedded C we are going to use this volatile keyword. That means it indicates the compiler that the variable value is subjected to change, and whenever the C or the compiler wants to read that value, it has to read from the memory every time it is being referenced. Now, very importantly, we will look into this interrupt latency. Interrupt latency is the amount of time the processor takes to respond to the interrupt. And interrupts are a tool for getting better response from our systems, and the speed matters a lot. The speed at which the interrupt is going to be serviced or the interrupt gets the response is what we call interrupt latency. There are certain factors on which this interrupt latency depends. The first one is the longest period of time during which the interrupt is disabled. If the interrupts are going to be disabled for a longer time, that means it takes longer time to service the interrupt. This is first important factor. The second one is the period of time it takes to execute any interrupt routine for interrupts that are of higher priority than the one in question. That means if an interrupt that is presently being waiting for the service is of a lower priority, means before getting this lower priority interrupt serviced, all the interrupts which are of higher priority than the one in question has to be serviced. If there are many interrupts that has to be serviced prior to the one it is requesting, then it takes a longer time. And the next important factor is how long it takes the microprocessor to stop what it is doing, that is to do the necessary bookkeeping and start executing the instructions. We have discussed this earlier that context switching happens prior to servicing the interrupt, that is pushing the contents of the register onto the stack prior to jumping onto the interrupt routine and then popping those contents. If that itself takes a longer time, then it takes a longer time to service the interrupt. This is one more factor. The other one is how long it takes the interrupt routine to save the context, the previous one, along with it how much time it takes to respond. Put together we call it as a response. Waiting in the ready queue along with the execution time put together is what we call it as response. So, interrupt latency refers to the amount of time it takes a system to respond to an interrupt, and there are certain things by which we can reduce this latency. We desire, like, as soon as an interrupt request comes across the processor, it has to be serviced. So, there are certain factors which we can through which we can reduce this interrupt latency. The main intention is to reduce the interrupt latency. So, by writing efficient code, we can reduce the time it takes to respond to the interrupt, and also the context switching, that is the factor 3, is not under software control. Though an efficient program is written, context switching time cannot be changed by writing efficient code, and factor 2 is one of the reasons that is generally a good idea to write. That is, I told about the priority. If a higher priority interrupt is being executed, then the lower priority ones have to wait for a longer time. So, if we write the interrupt routines very short, that means many interrupt routines can be serviced at a faster rate. Now, let us take an example of disabling the interrupts, and we shall see whether given a deadline can it be solved within the given deadline. Here is an example. So, here we have to disable the interrupts for 125 microseconds for the task code to use a pair of temperature variables it shares, and you have to disable the interrupts for 250 microseconds for your task code to get the time accurately from the variable it shares. And all these things has to be responded within 625 microseconds when the interrupt routine gets a special signal, and in order to execute this task it takes 300 microseconds. So, let us see that with the help of a timing diagram. Here this is the interrupt request. We have seen that it needs 250 microseconds to service the interrupt and 300 microseconds to complete the execution of the interrupt. So, put together 250 plus 300, that will be equal to 550 microseconds, and the time limit was 625 microseconds, and within the given deadline of 625 microseconds the task is able to complete. Let us look into another example wherein in order to reduce the cost of the processor, the microprocessor which runs at half as fast as the previous one is considered. So, now it runs at half the speed as the previous one. That means it takes 500 microseconds to complete the interrupt routine, and instead of 300 microseconds for the execution, it takes 600 microseconds. So, 600 plus 500 microseconds means it requires 1100 microseconds, which is much longer than the 625 microseconds, and the task cannot be completed within this given deadline. Another example is, suppose a networking capability is added to the system which needs 100 microseconds to do this work. Now, as the previous case, 250 microseconds to service the interrupt, 100 microseconds in order to service the interrupt capability, and 300 microseconds for the execution. So, if the networking capability has got higher priority, that means 250 plus 100, that is 350, plus 600 means put together it will be 650 microseconds, and it cannot meet this 625 microseconds deadline. Suppose the interrupt execution is at higher priority than the network, means it will be 250 plus 300, that means within 550 microseconds the task can be completed. Now, another last thing is, instead of using enabling and disabling the interrupt, there are certain alternate ways by which we can avoid that shared data problem. Here is an example of it. So, here two temperatures are going to be read into two different variables. So, in the task code, if the task code is using temperature B, it is going to be read from temperature B, otherwise it is going to be read from temperature A. So, if it is the task code is using B, the task code is using B means temperatures are going to be read into variable A. If the task code is using A means temperatures are going to be read into into the variables B. Thereby, instead of using enable and disable, we can avoid the interrupt routine from interrupting the instructions.